Hi, I'd like to introduce you to a next generation of where the touch bar, the Apple touch bar, can be really executed in a more advanced and far more powerful version. This is what we call Neo Keys, and we explain that it's a mixed media way to do everything. One keypad, infinite modes, a single pattern of use, learned instantly for physical keys or touchscreens. In this instance, so what you're seeing here is a 3x4 array that's of basically commands for any context. Here you have faces where you could, for instance, click and dial that person or access their social media or something. And you have a vertical array, but it could be laid out any other way you want. That gives the user top-level control into whatever app they want to be driving having access to commands through this keypad. And then on the left you have a deep dive into sets of 12 or how many the array has been designed for whatever keypad it is, sets of commands for the app that's been chosen by the user. So here we're showing you an example of a 3x4 array, but this could be a full QWERTY keyboard. It could be any array. The high-level controls for choosing the app for which the commands and the command sets will be available, we've positioned for ergonomic reasons on the right, but it can be located otherwise. It's scrollable, and there could be 2 or 4 or 5, but it's scrollable up and down, so you can access as many apps or groupings of apps this way as you want, or as the user wants. What you're seeing here is that the keys that there are screens associated with each key, and the keys have no labels. That's extremely powerful if a user has a way of allocating to the keys a set of commands that they want at the time that they need them. And that's why you have the navigation system that lets a user choose an app and switch among apps very, very fast, and within an app switch amongst sets of commands very, very fast. In this instance, we happen to have pulled out a set of keys that are also labeled by icon, such as the return key and the back key and the space key, and pulled them down here and organized them for ergonomic reasons. They may or may not need to be here depending on the context. This can be a physical overlay over a touchscreen. It can be purely a virtual keypad and virtual keys, or it can be implemented with physical keys and displays either with the physical keys as an overlay or with actual physical keys, designed the way they are built into keyboards nowadays, but with keys with a display associated with them. And we have developed the hardware mock-ups and the roadmaps for how to do this, even on tiny devices much smaller than smartphones you have today. So here's what we're talking about: this mixed media keypad that lets users have access to full sets of commands and with a single pattern of use. So you can, once you know where your commands are that you want, you don't even have to look at the keypad to use them, so your eyes can be up on high value add content, which is critical. So let me run through a few contexts for you. Here's the keypad with a traditional telephone numeric layout, but you can have, and you're in a telephone app, but you can click into a conference mode or a video conferencing mode or any other mode that the telephone app happens to have. You can, and anytime in the video, you can stop and read more about these things. Here you have an example of how English text entry could be allocated. If you had a full QWERTY keyboard, you might not do it this way. If you had a 3x4 array, you might do it this way. The high-level commands give you text, punctuation, 0 to 9 in calculator format, and arrows, which are very, very important for full text entry, punctuation, numeric, and arrows. Arrows would include things like home, end, up, down, and these things. Then in text you have A to L, M to X. If I clicked on M to X, these would jump to M to X. Y to Z, and whole words or whole phrases, and you can scroll down, and these can be programmable by the user. So the user could have whole paragraphs allocated to a single key that they could set the title for. This works, as you can, if you were to read this in any language. For instance, we've developed a Chinese text entry app around this that lets the user enter text entry by Chinese brushstrokes, and it then allows any font designer to design individual fonts of Chinese brushstrokes, from fascinating calligraphic versions to simpler, modern, or various versions, giving the Chinese language a much deeper, much more natural to itself ideographic expression, with almost an infinite number of fonts developable by anybody, that then can be used to write any Chinese character of any kind quickly and easily, especially if you add predictive text entry analysis into it, with a keyboard literally the size of 3x12 with 1 to 4 keys on either side. It's really fascinating. We've also done this for Japanese, and where you have katakana and hiragana, and you have we've done it in multiple other languages, and the user can flip between them whenever they want. So the keyboard, again, isn't labeled. The keys aren't labeled anything. And especially that's important when you don't label keys at the time of production. The device can be shipped anywhere in the world, and it's just software that can be the choice of the user, can flip on the fly between Chinese and English and Cyrillic and anything else. And now you're going to see how we jump into commands. This would be, for instance, commands for a photo app or a camera app, and here you have various options. The user has chosen that app, but there are sets of 12 commands as you jump between these 4, and it's scrollable, so there can be as many. Not all have to be filled in by the app developer. The app developer can choose how to allocate access to different commands however they want within the context of this framework. Here is accessing web video sites, for instance, and you could jump between video sites and TV sites and movie sites and various other things. In this instance here, you have the top 9 allocated to one-click access to these websites, and then you have the bottom array used to present an ad, and that could be developed as a single ad across the whole, or it can be 3 separate chiclet ads, without disrupting the user's experience of the upper keys. So you can generate revenue off your keyboard in a very, very powerful way in this context by app. Here you have a game app where a user has chosen a specific game, any one, doesn't matter, and that game has sets of commands in it. So the user can, and then the keys present the commands to the user. So 1, it's much easier to learn how to use a game in depth, and 2, once you know it, it's like touch typing. Your eyeballs can stay up on the high value add, and your fingers can fly between the commands, knowing exactly where they are because of the single pattern of use with no exceptions. So it's a very powerful way of creating a much more interesting gaming experience, and one that users can get into much, much more deeply, because you can have deep sets of commands, but they're all visually accessible without almost no learning curve by the user, because the game app developer can control how the keyboard looks and how they present the commands, not just in one set of 12, but in as many sets of 12 as they want. And in fact, the system can be designed so that the app developer actually can have access to what we would call meta keys underneath a single key here. So there could actually be even more sets than this related to one specific game. Here's a different example. This would be, for instance, TV controls, and you can have, play controls lists, enter all sorts of things, and plus an ad space. And you can go way beyond this. The sky's the limit. Here we have a music app, for instance. This is also fantastically powerful for lots of other contexts, such as augmented reality and virtual reality, where users need a powerful way of entering commands of any kind, whether it's text or anything else, but they don't want the head-up display to be showing the commands and disrupting that experience. This a tiny keypad that's either attachable to the arm or anywhere else, that is one-handed, full command entry at any level of depth of commands, can be developed using this. And same with for NASA, this is basically a programmable keypad with experiments, and in any text language at all. So if you have multilingual astronauts, which you usually do now, they can have a single keyboard that's smaller, lighter than current QWERTY keyboards, that is much, much more powerful, because it's not only works in any language without any overlays, but it also is programmable by experiment, and it can be attached to an arm or anywhere else, and it's completely mobile too. So this is a much more powerful system. If you'd like to learn more about this next generation, think of it as a next generation touch bar keypad, although we have patents on this that predate that by a lot. Let us know. You'll find my contact information at the end of the video. Thank you very much, and we hope you're intrigued by this. Please contact us. Thank you.